who's back. It's another Mac episode from Mr. Mac. Alright. So, for task 4, what we're going to be going over today are cubes and cube roots. So what I put on this table is we have a chart that's pretty much mapping out all of the roots. We have our perfect squares and we also have our perfect cubes. Alright, so inside I'm just going to put down some information. For instance, when we find a perfect square, alright, we're basically taking the root of the number 1 that's right over here, and we're doing 1 times 1, and we get the answer that is above 1. Alright? For the number 4, we're doing 2 times 2. So when we find these perfect squares, we're taking a number and multiplying it by itself to get the perfect square. And when we find the perfect cubes, we're taking the root and we're going to multiply it by itself 3 times. Alright? So when we look over here, we have the square root symbol for question number 1 is the square root of 81. Now, it's kind of hidden, but there's really an invisible 2 right there because we're trying to figure out what number times itself twice will give us a product of 81. That number happens to be 9. Now, if you happen to look over here, you look for the number 81, and once you look at that number 81, you go up. Once you go up, you see that the square root of 81 is 9. Next one, the square root of 225. Now, because I'm pretty decent at math, I know 10 times 10 is 100. Alright, I can go all the way up to where this answer is, and the square root of 225 is 15. Now on to the next question, the square root of 64. What number times itself will give us a product of 64? That answer is 8. And lastly, for question number 4, we want to know the square root of 196. What number times itself will give us 196? That happens to be the number 14. Now let's move on. Question number 5. We're going to be trying to figure out between which 2 consecutive integers do the following square roots lie. Alright, so we're trying to find the square root of the number 11. So what I like to do is, on my chart, I want to focus on the perfect squares and ask myself first, is the number 11 a perfect square? No, it's not 1, it's not 4, it's not 9. Alright, so what I realize is that, okay, it's not a perfect square, but it falls between the perfect square of the number 9, the square root of the perfect square 9, and it's going to fall between the perfect square of the number 16. The square root of the number 9 is 3, the square root of the number 16 is 4. So I would say that it's going to fall between the numbers 3 and 4. Alright, and that's going to be specifically because 3 squared, as we mentioned, is equal to 9, and also 4 squared is equal to 16. Next one, the square root of 39. So I want the square root of 39. I want to focus on my perfect squares. I went all the way to 9 before, so now I want to continue from 16, 25, 36, I'm getting close, and then we jump to 49. So I say, okay, I may not know the square root of 39 because it's not a perfect square, but I know the square root of 36, which is the number 6. I know the square root of 49, which is the number 7. So I know that 6 and 7 is going to be the 2 consecutive integers that they're behind. And when you think about it, we know that 6 squared is equal, sorry about how bad that came out, 6 squared is equal to 36, and 7 squared is equal to 49. Next one. So our next question is figuring out the 2 consecutive integers where the square roots lie for the square root of the number 83. Now my chart unfortunately ends at the number 81. I know the square root of 81 is 9. Alright, so I'm going to just write that little note down for myself that we know that 9 squared equals 81. Alright, but when you think about what 10 squared is, 10 squared is going to be 100. So I know it's going to fall between that 9 and 10. And when you have your test or even your task packet, you want to make sure that you continue with your chart. Alright, I was limited on space, so I couldn't fit all the numbers, and that's okay. So for my final answer, I'm going to say it falls between the consecutive integers 9 and 10. And when we say consecutive integers, we mean the number right after one another. Like 1, 2, 3 are a set of consecutive integers. 6, 7, and 8 are a set of consecutive integers. For the last one, we want square root of 127. So what I can do up here is I can actually continue this chart. from our last question, we came across 9 squared is 81, 10 squared is 100, 11 squared is 121, and then lastly we have 12 squared. That gives us 144. So when we look at that square root of 127, we end up seeing that it's going to fall between these values over here, because 11 squared was 121, 12 squared was 144, and the square root of 126 right between those. So I can say my final answer will be 11 and 12. Now on to the next few questions with perfect cubes. Now I like these questions because it just wants us to evaluate. We don't have to worry about the two consecutive integers. So the cube root of 64. Now what may happen to some of us is that we completely forget our times tables. So I want to show you a little trick that I realized. Alright, when you look at the chart that I made, 1 times 1 gives us 1. Alright, now let's look at the next one over here. Alright, I'm going to circle it. 2 times 4 equals 8. Alright, taking the number to the first power, 3 to the first power, times 3 to the second power gives me 3 to the third power. Look at that. Also known as 3 times 9 gives me 27. So if you do this correctly, you can always find out the perfect cubes even if you're having a hard time. So when I'm looking for the cube root of 64, I see I have 64 as a perfect cube, and its root is the number 4, because 4 times 4 times 4 gives us 64. The next one, the cube root of 27. I know that the cube root of a regular 27 is 3, but since we're talking about a negative 27, it's going to be a negative 3, because negative 3 times negative 3 is positive 9. Positive 9 times negative 3, negative 27. The cube root of 125, as we can see in our chart, perfect cube, its original root was the number 5. And lastly, the cube root of negative 8, that will be negative 2, since the cube root of a positive 8 would be a positive 2. Last but not least, question 13. Place the following numbers on the given number line. First number we have is the square root of 36. We can ask ourselves, what number times itself will give us 36? So I know that 6 times 6 gives me 36, so I know that that's going to be 6. I'll write the number 6 directly underneath. Negative 3.7 is pretty much self-explanatory. We should be able to find it on our number line. 5 over 8 is a positive number. Alright, it's a fraction. Alright, where the numerator is less than the denominator. So I know it's going to fall between 0 and 1. And lastly, we have the square root of 17. I know 4 times 4 is 16. 5 times 5 is 25. Alright, let me say that again. 4 squared is equal to 16. 5 squared is equal to 25. So the square root of 17, is going to fall between the whole numbers 4 and 5. So I'll just write that down so we remember it's going to fall between, alright, just shorten it, 4 and 5. And you tell me that it's going to be closer to the 4 because the square root of 16 is 4, and 16 is 1 unit away from 17, while 25 is 8 units away. So let's go ahead and start graphing. Alright, so I'm going to use my green, and above the number 6, we have the square root of 36. Alright, the next one, negative 3.7. I want to go to the left of my 0. Negative 3.7 is going to be a little bit closer to 4, so I'm going to draw my little arrow over here, and we got negative 3.7. Good job. 5/8, a fraction where the numerator is less than the denominator. It's going to be between the numbers 0 and 1. And 4/8 represent half, so it's going to be slightly past the halfway mark. And we got 5 over 8. And then the last one, square root of 17, is going to be between 4 and 5, but since 17 is closer to 16, I'm draw my little arrow right here, my little line, and it's the square root of 17. And that's all, folks. Good luck.